Hi guys, so for today's lesson 6.4 we are going to be looking at interpreting statistical summaries. Okay, so basically what does that mean? We're going to be looking at today how to depict data using graphs, or how to illustrate data using different types of graphs. Okay, so we have three different types of graphs. Number one here, you can see it's written down on the slide, multiple bar graph. So a multiple bar graph is a bar graph that displays two or more sets of data at once for easy comparison purposes. Okay, so what do we mean by that, or what does that look like? You can see this graph here, and this is showing us, based on the title here, population of major European countries in 1997 and 2007. So you can easily compare the population changes for each country from 1996, which is the orangey red color bar, versus 2007, which is the yellow bar. So each country is listed here on the x-axis, so you can quickly see, Germany's population over those 11 years only increased a little bit, whereas Turkey's increased by 10, 11%. Okay, so this type of bar graph basically lets you to easily compare two quantities because it shows them side by side. Okay, so that would be the first type of graph that we're looking at today. The second type of graph is called a split bar graph. So a split bar graph, and just look at the definition here, is a stacked bar graph. So stacked meaning instead of having your quantities like we did over here, if I go back side by side, instead stacked means one on top of the other. So what that would look like, if I scroll down here, is in this example we have favorite sport of grade 8 students, and then it's divided into girls and boys. So instead of showing girls and boys side by side like the first graph would have, a split bar graph basically stacks the two pieces of data, or the two quantities, one on top of the other. So it's you see the girls here in the bottom part of this bar for basketball, and then you see the boys on top there, and then same thing for badminton, same thing for volleyball. Okay, so the difference here is instead of showing the quantities side by side, we show them stacked one on top of the other. Okay, and this is a graph that is used to compare the parts to the whole. The bars in a stacked bar graph are divided into categories, and each bar represents a total. So here you can see girls, you can see boys, and you can take a look fairly quickly, and then you can see the amount of the total that the girls make up. So the girls are right up to there. So they make up a total of approximately, let's say, I don't know, that's maybe about 16, 17 out of 39. Okay, so that is your second type of graph. And the third type of graph is a relative split bar graph. So we just did split bar graph. The difference between the split versus the relative split is the relative split bar graph changes the data into, or the quantities into, percentages. Okay, so the split bar graph just took your total number, the raw data or the raw numbers, whereas a relative split bar graph converts those numbers as percentages of the whole. Okay, so just reading here the definition, this graph shows the percentage of the whole of each group and are plotted by the percentage of each value to the total amount in each group. So all of that basically wrapped up in, to summarize that, is basically it's the same thing as a split bar graph, but instead of using the raw numbers, you are using percentages. And your total here, percentage, will total to 100, right? So that's one thing to keep in mind. Okay, so it makes it easier to see the relative differences between quantities in each group. Okay, so if I look down here, we're looking at different sports, and it's showing us how many, I guess, games were won by the visiting team versus won by the home team. Okay, so here a little bit easier to see as how much won by the home or the visiting team is made up of the total. So for example here, In baseball, the home team is in blue, so we can see it's right around, probably a little bit above 50%, maybe right around 50%. If we look at hockey, the percentage for the home team goes up to just over 60, meaning the percentage for the visiting team would be just under 40. And then finally, basketball percentage is just above 80, so let's say about 81 even. And we can quickly see then that the remaining 19% will be won by the visiting team for the basketball games. Okay, so those are your three types of graphs that we're going to talk about today. And just a couple of other definitions in terms of the data. We want our data to be reliable first off. And what do we mean by reliable? Let me just scroll down here a little bit. The results of a study that can be duplicated by another study. Repeated trials would produce accurate data, produce stable, consistent results. So if your data to be reliable, it can't be all over the place. If you do multiple studies, you're getting consistent results, stable results. So if you have stable and consistent results, we would call that reliable. And the second type of data, or the second criteria that we want our data to have, we want all data to be reliable and we want it to be valid. Okay, so valid, I think, would go without saying. We want it to accurately represent the population. Okay, if your data is not valid, it's not very useful. Okay, so you want your data to be both reliable and valid. Okay, so we've looked at all three types of graphs, and we've talked about reliable and valid data. And now looking at the examples here. The first example says create a split graph and relative split graph. Okay, so remember, the split graph is just going to take the raw data, or the numbers you see right here, the 300, 134, 243, and 233, and use them as is. Okay, so what we have here is which lunch period, either period 3 or period 4, do junior students have, or how many junior students have period 3, how many junior students have period 4, and then the same thing for senior students. Okay, so to create our graph then, we're going to have to stack the numbers on top of each other. So we're going to have junior students as our first bar, and in that bar, we're going to show 300 students, junior students having period 3 lunch. And then on top of that bar for 300, we're going to place the bar for period 4, which will show 134. And then do the same thing for senior students. The first part of the bar will go up to 243, showing the number of senior students that have period 3 lunch. And then the second part of the bar, again, we're going to distinguish that. You can either use different colors or a different pattern or whatever, but distinguish the second part of the bar, and it'll be stacked on top of the 243, and that'll represent 233. Okay, so what will that look like? We see it right here. So juniors, period 3 lunch, we have 300. So period 3 is represented by the red. So we draw our red bar up to 300. Period 4 is represented by blue, and we can see period 4 junior students is 134. So we draw the blue portion of that bar on top of the red portion, and that goes from 300 to 434. So that blue part represents 134. Okay, same thing now with the senior students. We see in our table here that senior students, 243 of them have period 3 lunch. So our red bar here for seniors will go up to 243. And then 233 have period 4 lunch. So from that 243, we got to go up another 233 to the top here, which will be represented by the blue portion for period 4 lunch. Okay, so there's your split graph. To do the relative split graph now, we would have to then express these as percentages of the total, right? So we see the total of 434 here. So to get the percentage of junior students that have period 3 lunch, we're going to do 300 divided by 434. And then percentage for junior students with period 4 lunch, 134 divided by 434. And then do the same thing for senior students, get the percentages. And then we use those percentages in the graph for the relative split graph. And it would look like this. So remember, your percentages obviously have to equal up to 100. So your bars will both, once they're stacked on one another, will be going up to 100% for junior, 100% for senior. Figuring out which portion or how much the juniors, how much is going to be period 3 for each and how much is going to be period 4 for each is going to be by figuring out the percentages. So juniors with period 3 lunch, you can see here is 69%, which would mean juniors with period 4 lunch is 31%. So again, however you want to distinguish, here we're using diagonal lines for period 3 and a fully shaded bar for period 4. So 69% is represented there, and the 31% is represented there by the area or the part of the bar that is fully shaded. And do the same thing for seniors, get the percentages. 243 divided by the total of 476 gives me 51%. And then 233 divided by 476 gives me 49%. So period 3 here by the diagonal lines is going to be 51, so just over 50 to 51. And then from 51 to 100 is the 49% that represents the amount of senior students that had period 4 lunch. Okay, so there are two quick examples in terms of how to draw a split bar graph and a relative split bar graph. Okay, so that's it. Hopefully not too complicated, and it's fairly straightforward. But again, if you have any questions, as always, feel free to email and ask away. Okay, so we'll leave it at that.